Okay, so let's go over this question here. It says points A, B, C, D, and E represent snow shelters in the Blackburn National Forest. These snow shelters are illustrated in the following coordinate axis. Okay, so we have these points here, A, B, C, D, E. Suppose you get hurt here. Suppose you get hurt. Suppose these little points here are people that are either out of gas or their snowmobile crashed, or they they're hungry, or they're dehydrated, or they're frostbitten. This we want to know. We want to create regions like this that would show us where the closest snow shelter is. Okay. Now they don't start out with a question like this. They first just say, "Hey, calculate the gradient of the line segment AE," which is this right here. But just to kind of tell you where they're going to go with this question once we flip the page, they just give you this scenario, and they're talking about snow shelters and a forest. So, and then they just ask you to find the gradient, which is the universal word for slope. So here's the slope formula. This is the easiest thing you will ever do on the IB math test. Please don't miss it. It's 2 points. Okay, so the slope is 1/2. That's the slope between A and E. Okay. Now, where are they going with this? So, park ranger draws 3 straight lines to form an incomplete Veronoi diagram. Here is the word, the brand new thing that I've never heard of up until this, and you probably never heard of it either. But just to go back to this, a Veronoi diagram is created by taking the perpendicular bisector between any 2 points. So if we take this distance here and we find the midpoint and we create a 90-degree bisector here, this is the perfect line, and this is the perpendicular bisector of these 2 cities, okay? And this one is the perpendicular bisector of those 2. So this Veronoi diagram is created by the perpendicular bisectors of each set of points. So if you look at points E and C, this line right here is the perpendicular bisector. It's in the middle of E and C, and it's perpendicular. This line here is the perpendicular bisector between E and D. And hopefully you can visualize that. So if you take the midpoint and you do a 90-degree line, this is the perpendicular bisector of E and D. This line right here is the perpendicular bisector of B and E. So if I draw a line segment to B and E, you take the halfway point, you do a 90-degree angle, that is that one there. The reason why it's incomplete is we're missing one more. That's between A and E. All right? So I'm going to draw that one in red here. We are looking for, here is the midpoint, and we're going to try to draw the perpendicular bisector for that between points A and E. It's missing that one perpendicular bisector. So this will be on the test in May for sure. Whenever you see a Veronoi diagram, you just think perpendicular bisector, perpendicular bisector, perpendicular bisector between each set of points. They went ahead and found the other 3 perpendicular bisectors for you. You have to recognize that it's missing one, and that's between A and E. And it's no coincidence that they asked us to find the slope of, or the gradient of, A and E. So this is a piggyback question. They're talking about AE here, and we had to find the perpendicular bisector of AE. So here's a rule of thumb. Whenever you guys are ever stuck on an IB question and you're like on part B or part C, always look back at the part right above it. It usually, you use information from the previous question. Okay, so find the equation of the line which would complete the Veronoi cell containing site E. So we have to give our answer. We're used to writing it in slope-intercept form, but I'm going to go ahead and do this because I'm used to this. and then we will rearrange the pieces to make it look like this. So we have the slope of AE, which is 1/2 on the other side. The opposite reciprocal slope is called the normal. Okay, you folks in my pre-calculus honors, on that one worksheet, you guys found the normal to the tangent line of the derivative thing. So remember, you just take the slope, you flip it over, and you change the sign. So that is the slope we're going to need to find the equation of this red line. Okay, now we need a point. We need an x value and we need a y value. We need the coordinates of that point because we have the slope of the red line. It's the normal or the perpendicular to that. So it's the opposite reciprocal. Now we need the midpoint. So we need the midpoint of AE. That's point A. That's point E. The midpoint is the average of the x's. So 10 divided by 2 is 5. 1 plus 3, the average of that is 2. Okay. So 5, 2, and if you look on the graph here, here's 4, here's 6, that would be 5. Okay. And this is up 2. So notice that my numbers are jiving with the diagram. Okay. I looked in the formula sheet that you're going to be getting when you get to take the test. The only thing related to the Veronoi diagram, the only formula sheet, is how to find the midpoint of two ordered pairs. So this is just what I did. It's just the average of the x's, comma, the average of the y's. And this is what you need for the Veronoi diagram. And I think this is the only time you're going to use this is for this question. Okay? But you're the one that's going to have to put that together. It doesn't stay in here, use this for the Veronoi. You're going to have to be doing that going into the test, knowing that that's what you're going to look for. Okay, so we have our x value of 5, and we have our y value of 2. Now the rest is just, I'm going to distribute the 2 here, plus 10. And notice they want this in this format. They want everything to the left of 0, to the equal sign. So out of habit, usually what I do is I put this in slope-intercept form as I add the 2 to both sides to get y equals negative 2x plus 10. But in this case, I'm going to move everything to the right, or to the left, excuse me. So if we do this, I got the 2x first, plus the y, minus the 10 equals 0. So why do they want it in this format? I don't know. We're used to seeing it in slope-intercept form. But I went ahead and used this formula, and then I just moved the pieces around. So we have the 2 here, the b value would be 1, and the d value, or the constant, would be a negative 10. So in other words, this is the perpendicular bisector of AE. That completes the Veronoi diagram. Questions, comments, concerns so far? I don't like teaching this way, but we have to. So you guys need to help me out and talk to me. Okay, I hope so, because I'm trying my best. Okay, so what a Veronoi diagram tells you is that these are the regions. If you are hurt anywhere in the yellow region, the closest site or shelter to you is point E. And this would be very, very helpful for a national park to develop these regions. That way, if you're hurt at a certain location, you can find the closest shelter. So, in context of the question, explain the significance of the cell containing site E. So, what I came up with is any location within the cell, and I'm talking about the yellow, containing site E is closer to site E than any other site. E would be the closest shelter. And there's probably a lot of different ways to explain this. But if you understand what a Veronoi diagram calculates, it's very, very practical. It's practical when you think about it in terms of shipping. So these are the points going to people. This is just the opposite. You got someone hurt right here. It's all snowing. You don't know where things are at. You can't just follow the streets. E would be the closest one to you. Okay? So this is the Veronoi diagram. I'm going to be sending you guys a question via email to follow up this. I would like you guys to try it just to make sure that you understood what I talked about. And that will kind of close the loop. And this is the last thing we're talking about in 2020. We're not going to have a huddle next week. So I would like to say goodbye to 2020, the IB huddles. We will reconvene in January and pick it up where we left off. So be expecting an email from me sometime tonight with a Veronoi example. It should take you a couple minutes. Please give that a shot. Send it to me back via email, and I appreciate it. So that's all I got for you. Any questions?